Hello students, now we are moving to the next point, that is explanation of the TRIAC. So TRIAC is again stands for, it is a triode for alternating current, also we can say, or it is a 3-terminal AC device. So here also we are giving the input, that is alternating current to this device, and this is also comes under the category, that is thyristor. Now how the symbol of the TRIAC is looks, we are shown here in the diagram. I want to show you this. This is a symbol of the TRIAC. Here also we are having two SCRs oppositely connected and 3 terminals it is having. So here MT1 and MT2, and this is a gate. So for MT1 we can say it is a main terminal 1, and MT2 it is a main terminal 2, and this is a gate. If you want to look at this symbol in the form of 2 transistor analogy, it looks like this. So here you can say there is a one SCR here and another SCR is here, oppositely connected, and the gate terminals of these two SCRs are commonly taken and connected to single gate, and the anode 1 anode 2 of the SCRs, what we have seen in the SCR single operation, here they combined and they made MT2 and MT1. This is called as a 2 transistor analogy symbol. And if you want to see the physical structure of the this TRIAC, now you can observe 2 SCRs means one SCR is having a layers of 4 and the 3 junctions. So now 2 SCRs are kept oppositely. Now obviously we can imagine that is one PN structure of the SCR is at the left side, another NP, that is opposite type of the SCR is at the another side. So these are called as a physical constructions how they are made. And here also we are having the 3 terminals gate, MT2, MT1. Now if you want to see the 3-dimensional diagram of this structure, sorry, it is a 2-dimensional diagram of the structure, it will looks like this. So here we can combined structure. So if you are both SCRs, your structure is going to combine, it is a cross-sectional view also we can say. Here we are having the layers P1, N1, P2, and at the below we are having the N4 and N2, and at the top N3 layer is there, and the gate connection is given to the N4 N type of layer, and MT1 is at the N2 layer, and MT2 is at the P1 layer. So now this is a physical structure also we can say. So now how the operation of this TRIAC is going to occur, we can observe with the help of one small circuit. So here I have shown the TRIAC is connected to the main AC supply, where the AC supply is given to the terminals of the MT2 and MT1. Main terminals are given directly with the AC supply, and with the help of the gate we are connected one positive supply and one switch is there. Gate and MT1, in between these two there is a one power supply and again one switch is there, and this operation can be explained when the switch is open. So what we can say, there will be no gate current, and the TRIAC is, we can say, it is in a turn off mode. So obviously when gate is not given, so and you are applying supply AC, so it is initially AC supply is very less, and gate is also not connected, that is means switch is open. So you can imagine there is no flow of the current in the TRIAC. So if it is not conducting a correct, means it is a off condition. Even with the no gate current, the TRIAC can be turned on. How it is going to be turned on? So if you consider you are not applying a gate, initially it was not conducting, but it can be conducted when AC supply is going to be cross the breakover voltage of the TRIAC. So breakover voltage means what? It is in the previous class I have said it is a minimum voltage required to break down the junctions of the thyristor. So in the TRIAC what we have seen, same operation is going to happen in this. TRIAC is also given with the supply of the AC and TRIAC is also given with the supply of the AC. When the AC crosses, obviously the AC current starts increasing in the maybe it is in the positive half cycle or it is maybe in the negative half cycle. It reaches to highest peak value from initial 0 to maximum value. So in between that, initially it is a 0 and when it starts increasing it may reach at some point that is called as a breakover voltage. When it reaches to that breakover voltage, it is minimum voltage required to break down the junctions of the TRIAC. So that time the TRIAC start conducting. So this is happens automatically turn on the TRIAC without the help of the gate. So turn on maybe happens, or when you say when you are going to close the switch of this, the switch means here what you are observing, this is a switch. So when you as soon as you are going to close this, so automatically the power supply is given to the gate terminal. It is somewhat voltage you are going to apply. So then what happens, the gate current starts flowing in the gate circuit. Then TRIAC can be made turn on before the breakover voltage which is minimum required to turn on the SCR by the main AC supply. Before that you can turn on the TRIAC. How? Obviously when the gate voltage you are giving, it is a minimum voltage or it is a one type of a extra voltage, it is going to help the TRIAC junctions to break immediately before the AC supply going to reach the breakover voltage. So we can make without consuming the maximum AC supply voltage, minimum using gate voltage we can turn on the TRIAC. So this is a simple operation. With the help of the gate we can immediately, whenever we need, we can turn on the TRIAC. So this is a operation of the just with the help of the circuit. Here one more point we have to remember, that is when you are going to give the gate current. So gate current it is requires very small amount of the current, that is we can say milliamperes. So when you are going to introduce milliamperes of the current, your TRIAC is going to be turned on. Maybe your two terminals, that is MT2 or MT1, maybe it is a positive to the MT1 MT2 or negative to the MT1. Whatever the potential supply you are giving to the MT2 and MT1, maybe it is positive half cycle, negative half cycle, terminals may be changed, but without considering it, whatever the gate current, that is milliampere current is there, it will turn on the TRIAC. And next we are moving to the VI characteristics of this, how the VI characteristics can be observed, voltage and current of this TRIAC. So now you can see this diagram. Here we are having again first quadrant, that is a quadrant 1 is this one, and again quadrant 3 is this one. In the first and third quadrant we are observing the curves of the voltage and current, and this is how it is at the from the both the sides TRIAC is working. So not from the only one side, it is from the both the sides it is working. How the SCR curves we have understood. So VI characteristics of the SCR, similarities are there in this. So initially AC supply you are giving and it starts from flowing from 0 to its maximum peak value. So and this is going to be turn on when the breakover voltage it is going to reach. So here you can say when MT2 is positive with respect to MT1, that time you are applying AC and consider you are not given the gate supply. So then here is one point, here I can show you. So this is a breakover voltage, it reaches to up to that the current will be minimum, it is nearly equal to 0, and when it reaches to the breakover voltage it suddenly turn on the TRIAC. Turn on means current starts flowing and the voltage drops to minimum. immediately voltage comes to down and current starts flowing with the maximum value. So this condition can be said as a this is a track is becomes the turn on. Same thing will be happen at the reverse bias when your terminals of the positive supply is changed. So here when you can say negative half cycle also of the AC supply is given, that time similarity break over voltage is here. As soon as it reaches to break over voltage, the track is going to be turn on, and here also your current is going to becomes very high, voltage going to be comes down. This is a simple concept of the TRIAC. So it is having SCR. If you understood, so you can implement the concept of the SCR VI characteristics in this TRIAC, and you can understand by keeping the curves of the SCRs, two opposite SCRs in the first quadrant and in the third quadrant.